All right, so again, we know the dilation versus stretch thing, right? Okay, you know the difference, yes? Okay. And so our notation for dilation, I'll just squeeze it in here, the mapping notation will look like this. All right. Dilation, subscript, center, whatever it is, comma, K, scale factor, right? Of some point, X, comma, Y, the arrow means maps to, right? Right?
Yeah.
K, X, comma, K, Y. That's assuming we're centered at the origin for our dilation, okay? So it's pretty simple. So the X version is the run of it, isn't it? And the Y would be the what? Rise. And if you have a point XY and you're centered at the origin, that whatever the X value is the distance from the origin, right? 0, if it's 2, 3, your 2, the run is 2, and the rise is 3. It's those numbers that are in the coordinates that you're starting at 0, 0. And later we'll look at the center's not 0, 0, right? So we got to do the rise and run from some other point, right? So it'll be something other than 0 plus 2 and y plus 2, okay? But if it's centered at the origin, it's real simple. Just take each point, multiply the x by k and the y by k, and you got your new dilated point, okay? You guys know there's between stretches and dilations, right? Yeah. So just real quick, if you saw it in mapping notation, okay? Dilation of xy maps to x, comma, 3y. Would that be a dilation or a stretch? Stretch. Because you're only, right? To be a dilation, they both have to be multiplied by the same number, don't they? The same scale factor to keep it proportional. With me? So if either one of these get multiplied by something different than the other one is, it's not a dilation, it's a stretch, okay? So down here real quick, is this right here, A, a dilation or stretch? Square root of 5. I mean, it's not a thing multiplied by it, whatever, okay? But the same, so K is a square root of 5, so that's a dilation. It's proportional and multiply the width and the height, the same number keeps them in the same ratio, which means in proportion, okay? This one here? Stretch. Yeah, all right, and whatever the, yeah, I don't know. Okay, now we're talking about rise and run a lot, right? So I want to just bring you up to speed here. Let's go to the notes page. I just want to clarify some things about slope. Rise and run is what we measure slope in, right? And like when we're counting and doubling or tripling the rise and run from the center, we're really doubling or tripling the slope, aren't we? Right? Yeah. Would be? And we're doubling or tripling like the original rise without reducing it, aren't we? Like to get from one point to the other, if it has a rise of 4 and a run of 2, we're doubling the 4 and doubling the 2, yes? We're not doubling the reduced point 2 and 1. Does that make sense? So a lot of time, most of the time, we take slope and put it in lowest terms. This is one case where we will not put slope in lowest terms. We're going to double the actual physical rise and run, whatever it is, okay? So in your notes page here, so, I mean, you guys know what slope is, right? What letter do we usually stand for slope? M. And in general, it equals rise over run, right? Now, the coordinate plane, how do you measure the rise? What values? The change in what values? Change in y, right? So rise and over run could be called change, E on there, right? In y over what? Change in x values. Okay? Now, if any of you move on to a science class like physics, chemistry, or something like that, there's a Greek letter that represents change. And maybe if you watch the movie Apollo 13, you hear them talking about this. Has anybody ever seen this? That is not a triangle. That is the Greek letter delta. Delta? Okay, so delta means difference, right? It's a Greek letter D. It's not a triangle. Mr. Morley's right.
Yeah.
That's not a triangle. That's a Greek letter delta. Change means a difference in two numbers, right? What's the change between 7 and 9? It's the difference between 7 and 9. Subtract them, right? Okay? So sometimes you might see, what?
The lunch is here.
Oh! Bonnie? I thought it was your dad, see? Okay. Come and get your lunch. Delta y over delta, difference in y, gets you to change in it, difference in x, right? So if you have like 2 points, x, y, x comma y, so like x1, y1 for the first point, x sub 2, x sub, or y sub 2 for the second point, how do you find the difference in the y's? What do you do to what operation? Like the difference between 7 and 9, what do you do? Subtract, right? So you take y2 minus y1. That's your change in y. Over what? Does that look familiar?
Yeah.
Slope formula from last year, right? Yes.
I remember.
So that just means you have some point x1 comma y1, the first one, and some other point x2 comma y2. We just use subscripts to say the first point and the second point. So you got the first x, the second x, right? Okay, got me? What's the hate? It's subtraction. So this change in y, that gives you your rise, and the change in x gives you your run. y2 minus y1. How do you get change? Two numbers. You subtract them. Just like you have to memorize it. You say, oh, I need to change the slope to change in the y. Well, I got to subtract it. You need to remember, okay? All right, let's go back. Everybody got this? Where are we? Okay, we did this, and now we're going to go over here. Okay, so here's the thing I gave you before. If it's centered at the origin, it's really simple, right? If you have a scale factor to tell you to dilate a triangle, the triangle is going to have 3 points, right? X and Y's. And so you just apply this to each of the 3 points. And that will result in your new dilated points if you do it to all 3. Okay? Down here, we're about this stretch dilation, obviously. Don't worry. Okay, so down here. So we're going to do dilation, centers at the O for the origin, right? 0, 0, right? And if it's at 0, 0, like the run to C is its actual x coordinate, right? You got that? So 1, 3 means from the origin, it's a run of 1 and a rise of 3. So numbers that are actually there. If our center was some other point, it wouldn't be 1 and 3, would it? For the run and rise, right? You with me? And we'll get to that later. It's not that hard, okay? So we're going to dilate with this rule. What's the scale factor? 2x, 2 what? What is 2 times 1? What is 2 times 3? That's it. Okay? And that's your dilation for that point. And again, if it's a triangle, you just do it 2 more times for the other points. Okay? Which is pretty easy when you start at 0, 0. But I will add the following in here. Okay? So basically, we doubled the rise, right? The y's. Okay? So double the rise, which is the y values, right? And double the runs, right? Double the run, which are the x values. That makes sense? So let me ask you this. What was the original run from the center to point C? 1. What's the new run? We doubled it. You get the idea? Okay? Ax comma ky. So basically, it was originally from the origin, the run was 0 plus what? 1. And the rise was 0 plus what? 3. Okay? Now it's 0 plus what? In other words, 0 plus twice that difference, right? So like to get from here to here, from 0 to 1, it's what minus what? What's the measurement? What minus what? 1 minus 0. And the rise from the origin to a rise of 3 is what minus what to get that distance? 3 minus 0, okay? So I'm going to complicate this notation a little bit, and it'll help us when we get to the center that's not 0, 0, okay? So really, the center is 0, 0, right? We're originally adding, 1 minus 0, okay? So we would have like this. 0, starting x, right? Plus, we're doubling the original run, which you said was 1 minus 0, right? With me? Just 1, doubling the 1, right? Okay, you done 1? And then the y value here is 0, so that was originally 0 plus 3. Now it's 0 plus, what was the difference? 3 minus 0? Oh, 2, sorry. There's a 2, double that, sorry. Are you kind of following me? So it's 2 times that change in y. But you see the change in x and change in y really simple here because it's 0, right? I mean, it's kind of redundant to put 0 plus anything or 1 minus 0. Isn't that redundant? But I want you to see where it comes from, right? Because later on it won't be so redundant. We'll be starting at the center of like 5, 4. It'll be slightly different, okay? So this is the 1 minus 0 was the original run. What? Run. And 3 minus 0 was the original what? Rise. And the scale factor is 2. So what did we do to the original run? Multiply by 2. What did we do to the original rise? And then this right here, this became 0. What's 2 times 1? 2. 0 plus 2. Right? So this became that. And what's 2 times 3? 0 plus 6. Right? So that, you see what I mean? Yes, turn. Okay. Okay. Stretch, raise your hand. I don't know. So, dilations from the origin, right? The points, the x and comma y, if it's at the origin, right, the x comma y is the run comma rise. It's run comma rise, not rise comma run, right? You say rise over when you leave with rise. But x is run, comma y is rise. Only if it starts at the origin. Those coordinates are because it's that x minus 0, which is still just the x, okay? All right. Yeah. Let's move on to the next page. Now we're doing a dilation 1/2. Same thing, right? So the run is just going to be, the x minus 0 in this case, and y minus 0. And what are we doing to each of those rises and runs? Multiplying by 1/2. It's a 1/2 on this page, right? Okay? So here's the origin, right? So if we're starting with A, what's the original run? 6. But you do that because that's 6 minus 0, isn't it? Okay? And what's the original rise? -4. But you knew that because it's -4 minus 0. Okay? Again, it won't be 0, 0 later. And so we're going to do half of this 6 minus 0, comma half of the -4 minus 0. And you don't need the zeros in there. That's why when it's in the origin, it's just kx comma ky. You get that because the x and y are the run and rise. So if we want to complicate this mess here, they're just doing half the 6, half the -4. Okay? Let's complicate it. So we started at 0, and we originally added for the run whatever 6 minus 0 is. But we're doing half of that. So now it's 0 plus now half of that run, comma, right? And then for the rise, it was 0 plus -4 minus 0, but now it's half of that. Half of -4 minus 0. Right? You guys are okay with nested parentheses, right? Okay. So this side, this is my original run, or just the new run, I guess now with all that in there, and this was the rise, right? Okay, but what is half of 6? And what's 0 plus 3? So you see? And then half of -4 is what? What's 0 plus -2? Does that make sense there? So maybe some of you are starting to think, okay, if the center's not at 0, 0, how are we going to do this, right? Okay? And so it became a reduction. So we just took half of that. So we get 3, -2 for that one. Did it for both of them.
So do we have to use the formula, like always?
Not for, oh, no. I'm just showing this to you. If it's centered at the origin, it's just kx comma ky.
Well, that looks like what we did.
I know, I'm preparing you for when it's not 0, 0. Okay? Say, look, they just have kx comma ky. And the reason it's that simple is because it's centered at 0, 0. But I wanted to show you what it actually is when it's not going to be 0, 0. Okay? All right. It's not a bad question, actually. Here's 1/3. Right? I'll do this one more time. So we're starting it there, right? The original point is what? What are we going to start at D? No, E, right? We're doing both of them. Whatever. Okay, doing both. Yeah. So what's the original run from 0, 0 to D?
3.
Yeah. Boy, they're way off on it, aren't they? It's kind of off. Okay. I never noticed that before. Yeah, well, whatever. Okay. So it's going to be -1/3 of 3, right? Or 3 minus 0, right? Okay. And then -1/3 of 9 minus 0, right? 0, 0, right? This is our kx comma ky, which is nice and simple. Start centered at the origin. But let's pretend the origin isn't the origin, right? This would be really 0 plus what, guys? Well, -1/3. And please don't ever put plus minuses together without parentheses. Okay? Times what? 3, technically minus 0, right? K times the original run, comma, 0 plus K times what? 9, the original rise. You got me? And you don't have to do that at the center at the origin. I'm showing you, okay? And that becomes a reduction. You'll do that for every point in the figure, and you'll get the correctly dilated points. All right? So let's go down here real quick. Now, these are all centered where? At the origin. So I don't need you to do the complicated version of it, right? All we have to do here is kx comma ky to get all of those, okay? You with me? So why don't you guys go through and do those? I'll pause this and let you see how you do. These are simple because they're centered at the origin. O is the origin. We'll just go through these quickly. So what do we get for the first set? -6, comma 10. These aren't going to take long. How about part B? 10, comma 40. Again, if you don't have parentheses around it, is it an ordered pair? It is not. How about the next one? 2, comma 8. And D? Well, good. Because that might be 8 times 1/8. Well, what's 8 times 1?
8.
Divided by 8. 1, right? So 1, comma, what's 8 times 3? Divided by 4.
6.
Oh, let's do it the other way. Watch. What's 8 divided by 4?
2.
Times 3. Okay? Put the calculators down. Oh, got to go backwards this time. So instead of multiplying by -2 to go the other way, what are you going to do? All right, so what do we get? -6, comma, +5. Are we good on that? And that's a 2.5 on the last one. What do you get? 5, comma, negative what? 2 times -5. Well, 2 times 5 is 10, right? What's half of -5? 2.5, so -12.5. Okay, pretty simple, isn't it? All right, so that's if it's centered at 0, 0, right? Because the change in y and change in x are just the coordinates of it, right? Those coordinates -0, it's just those numbers, okay? Now let's go. Hopefully you're a little prepared for this one now, okay? And if you get lost, I want you to think of what we did in the plane in the last section. When we dilated at some point, not the origin, We took the original rise and the original run and multiplied that by the scale factor and made that the new distance from the origin, rise and run, okay? So let's do it algebraically. So now this is not at the origin, okay? Huh? Sure is. Okay. Anyway, our scale factor is 2, and our center is now not 0, 0. It's at t. What are the coordinates? So instead of 0, 0, we're starting at -3, 4. Okay? So what we need to do is find what is the original rise to get to h.
2.
2, the rise. And what's the original run? That's your 5. Okay? So our rise over run is 2 over 5, right? So find the slope, right? So how'd you do that mathematically? What minus what? I know parentheses are.
6 minus 4 and 2 minus.
Yeah. y2 minus y1 over x2 minus x1. That would normally be like 6 minus 0 over 2 minus 0, right? But now it's not 0, 0. You follow me? So we really get this from doing the rise 6 minus 4 over 2 minus -3, right? That's our y2 minus y1 over x2 minus x1. You with me on that? This is, right, 2 over what? You sure about that? 2 minus -3 is 2 plus 3, 5. So this is the original rise and the original run. And what are we going to do to those? What are we going to do to that original rise and run? What's the scale factor? We're going to double each one's distance from the center, right? So take a look at this. So down here, so our 6 minus 4, right? Wasn't that our 2? Now be careful. This side is the rise, and this side is the run. When you do this up here, you have rise over run. So a lot of kids will tend to put this first because it shows first here. You got to be careful there. X is run, okay? So this is really -3 plus 2 times the original 6 minus 4. See what I did here? Right, instead of 0 and 6 minus 0. And then the right side, 4 plus twice. What was the original rise?
6 minus 4.
Did I get that backwards? I did. Say something. Yep, sorry. See, I made the mistake I told you not to. This side's the run, right? So this should be what? 2 minus -3. You can read that, which is 2 plus 3 you got, right? Now over here, starting at 4, instead of going up, or yeah, up 2, right? Up the 6 minus 4, we're going twice the 6 minus 4. Does that make sense now that you saw it with the 0, 0 maybe? So just instead of 0, 0, we're starting with -3 and 4, okay? Now, whatever we have here, so we don't reduce it, okay? Like even if this came out to be -4 over +10, you'd leave it, because that you didn't do that when you counted, right? You didn't reduce Lowell's term when you counted and doubled it, right? That makes sense? So this is when you don't reduce slope, okay? So let's see. That's 5, right? What's 2 times 5? And what's -3 plus 10? 7. This is 2, right? What's 2 times 2? What's 4 plus 4? 8. You with me? Okay. Let's look at another one, make sure we kind of get this. So now we're going to do a dilation of what? 1/4. So we need the original rise and run. What minus what? So the center is T, right? What is the original rise? What's the original rise? 8. 9 minus 1, right? Is 8. What's the original run? negative 12, right? In other words, what? 9 or negative 4 minus 8, right? Right? So this rise came from our 9 minus 1, and this came from our negative 4 minus 8. So this is our rise originally, and this is our original run. Now look, you notice we don't reduce that at all, do we? You're tempted to make that like negative what? Negative 2/3, right? Lowest term slope. In this situation, we'll leave it just like that, right? Look. So starting at a run of 8, instead of it, so this is really 8 plus 1/4 of, what was the original run? Negative 4 minus 8. We're going to take 1/4 of that original run. Comma, for the rise, we started at 1, right? No, 1. Something's wrong there. Wait a minute. Am I thinking of this wrong? Wait a minute. I got to be embarrassing. Okay. So starting at 1, we originally did a rise of what? 9 minus 1, didn't we? Right? But now we're going to do 1/4 of that rise. So plus 1/4 of that original rise, 9 minus 1. See where we're going with this? So what's negative 4 minus 8, guys?
Negative 12.
What's 1/4 of negative 12? Huh? Negative 3. What is 8 minus 3? 5. Okay, let's go to the other side. What's 9 minus 1?
8.
What's 1/4 of 8?
2.
What's 1 plus 2?
3.
Are you following that now? Do you see how, like, if you picture when we counted in the plane, just by counting the rise and run, and either doubling or you're taking 1/4 of it, right? We're just doing the same thing mathematically, but you get the rise and run from subtracting the y's and the x's, okay? But remember, when we do this part and get our slope, do not reduce it in this case, okay? So we don't simplify slope in any way, okay? Okay. Let's do one of these real quick. We got time. We'll go through this real fast before we go. Let's just do this. On the next page, I'll go through the first one with you real quick. So our center is G. There it is. Starting at 1 to 3, and we're going to 6 and 5. 6,5, right? So let's get the original rise and run. And we always have to do the point minus the center. That's our Y2 minus Y1. So this will be what minus what? For the rise.
5 minus 3.
5 minus 3 over what?
6 minus 1.
And what does that give you?
2 minus
2 over 5. So that's our original rise over original run, okay? But we're starting from 1 and 3, right? So down here, they just kind of a hand-holding thing. This is like what you saw me do, right? So starting, this side is this is the run side, isn't it? That's the rise side. So for the run, where do we start? 1 plus twice what?
6 minus 1.
Yeah, I'm just going to put the 5 in there, right? I just want to, okay, we can just put the 5 in there. 5, can't we? Is that what I did? Yeah. Okay, and for the rise side, where did we start? At 3? And we originally added what? 2, but we're going to add twice 2. Does that make sense? What's 2 times 5 over here? What's 1 plus 10?
11.
What is 2 times 2?
4.
3 plus 4, 7. Get the idea?
Yeah.
Do this one real quick. Just like we got time. Do that one real quick. And I will give you while you're working on that, I'll write down the problem set thing here. So your problem set, let's see.
Yeah.
Huh? I heard a yeah. What you got?
For total,
Yeah, for here.
negative 4, negative 7.
It is negative. Anybody else get negative 4, negative 7? Okay, let's do this real quick. So we got to do 1 minus 5 over 0 minus 2, right? Which is equal to -4 over -2. Don't even cancel out the negatives, right? Don't simplify it at all. You got me? Okay, hang on. So we started where?
I got negative 2.
2, and for the y's we started at 5, right? So what was the original run?
Negative 2.
-2. And the original rise?
Negative 4.
What is 3 times -2?
Negative 6.
What's 2 minus 6?
Negative 4.
What's 3 times -4?
Negative 12.
What's 5 minus 12?
Negative 7.
-7. Got it? Okay.